4.7 is called piecewise functions. All right, a piecewise function is a function defined by two or more equations, okay? So it's often going to look like this. Well, it's always going to look like this. This particular one has two equations. So, I've got this top part and this bottom part. All right, so f of x equals both of those things depending on what the x value is. If the x value is negative, then we would use the top row there. If the x value is 0 or positive, then we'd use the bottom row, okay? So for the piecewise function above, let's find f of 3 first off. So I'm looking at this and thinking, okay, here my x is 3, so I'm using these directions and thinking, it's got to fall into one of those two categories. So 3 is greater or equal to 0. So that means I'm going to use the bottom path. So I'm going to use this function then when I'm finding f of 3. So I'm thinking, okay, for this one, I'm using f of x equals 2x. Okay? And I'll solve that in just a second, but let's just look at part B and C and decide which road we have to go on, because that's important. This next one, my x value is less than 0, so that would be the top path. So then I'm going to be using, when x is less than 0, I'm going to be using this path, right? So for this one, I'm going to use f of x equals x plus 3. Okay, and then when x is exactly 0, it's got to fall into one of those two, and it falls into the bottom one because it can be equal to 0 on the bottom path. So I'm going to be using this path again on this one, okay? So then when I'm finding f of 3, that means I'm just going to do 2 times something. My input here is 3, so I'm just replacing the x with a 3 here, and that means that's going to equal 6, okay? Now this one I'm using something plus 3. My input here is -2, so I've got -2 plus 3, which is +1, okay? And then here I'm using 2 times something, and my something is going to be 0. So 2 times 0 is 0. Okay. So that's the idea. You got to choose the right path depending on what input you're dealing with, what x value. Okay. All right. So let's look at what some piecewise functions would look like graphed. All right. This can be a little tricky. So what I like to do is to split my graph up into sections. So I'm looking. Okay, this one it's very similar to the piecewise function above, where we're either using x values less than 0 or greater and equal to 0. So the place where my graph is going to get split up is at 0. Okay, so I've got two different places. So when I'm going less than 0, so that would be over on the left side of my graph, then I'm going to use f of x equals x minus 2, or you can just think of that as y equals x minus 2, okay? And that's going to go up to, 0, but I'm not going to have 0 as part of the graph. So that's using this part of the graph, okay? And then on the other path, when x is greater or equal to 0, I'm going to use f of x equals 4x, or you can just think of that as y equals 4x, okay? And that's going to happen, that will include 0 because it says it can be equal to 0 there. So that's just giving me that's not part of my graph. That's just how I'm kind of thinking about this, is that I'm going to graph this function on the left side of the graph. I'm going to graph this function on the right side of the graph, okay? So now I'm looking at this, y equals x minus 2. Well, my y-intercept here would be -2. And my slope would be 1, right? My slope is 1, or you can think of that as 1 over 1 for rise over run. That's in slope-intercept form, right? So let's think about that. I've got -2, so I'm going to very lightly put a little dot. I don't want to put a closed dot here because this is the border, and for this function, it can't be equal to any point on this. So it's actually going to be an open dot there to show this isn't going to be part of my graph, okay? And then from that point, I'm going to use the slope. So you could go up one to the right one, but I'm not using the right side of the graph here. So I only want to use the left part, so I'm going to go down one to the left one instead. And then I'd have a slope of 1, right? Up 1 to the right 1, up 1 to the right 1. But I'm only doing this part of the graph. Okay? So I've got an open dot there and an arrow going down to the left. Okay? On the right side of the graph, I'm using this function that I have in red pen. And here I have a slope of 4, or I could think of that as 4 over 1 if I write it as a fraction. And then there's nothing added to the end, so you could write a plus 0 there. So my y-intercept is 0, okay? And since my x value can equal 0 here, and I'm going to have a closed dot, okay, for that y-intercept, because this is going to be inbounds for the right side of the function, okay? And then I'm only going to use the right half, so I'm only going to graph this line on the right side of this. So then from there, I'm going to go up 4 to the right 1, up 4 to the right 1 to make another dot. And I've got my line, but I'm not going to graph the whole line. I'm only drawing it on the right side of the graph. Okay, so that's the idea. And you could have 3 functions or 4 or 5 or 6, any amount of functions. So you might have to carve your graph up into even more than 2 sections. Okay, so this one, again, we're working on the left half of the x-axis and the right half. So on the left half, I'm going to use y equals x plus 1. On the right half, I'm going to use y equals, I'll do this one in red, y equals 2/3 x minus 2. Okay, so both of these are in slope-intercept form. That makes it nice for graphing. My slope is 1, or 1 over 1, and my y-intercept is also 1 there. Okay, so let's put this in. So I've got 1 right here, but then I'm thinking, is this, can I put a closed dot here? Well, I can't, because x is not going to be part of this graph. So I'm just going to put an open dot there. Okay, and then if I'm using the slope, up 1 to the right 1, but that's not where I want to be graphing this part, right? So I don't want to graph anything on this side. I'm only using the left side there. So then the slope is going to give me these points. Because I could also think of this slope as -1 over -1, right? That would also equal 1. So I can go down 1 to the left 1. And then I've got my graph like that on the left side, okay? So for this side, I've got a slope of 2/3 and a y-intercept of -2. So let's start with that y-intercept at -2. Okay, it's okay to put a closed dot here. I need to put a closed dot because my graph does include points, an x-coordinate of 0, all right? And then slope is 2/3, so I'm going to go up 2 to the right 3. And then that's all I have room for, so I'll connect the dots, but I'm only using the right side of the graph there, okay? So that's what it looks like, all right? So on the next set of problems, we're going to do some reverse engineering. We're going to have the graph, and then we're going to write the piecewise function from the graph, okay? And I'm going to start with this part, which is called the restraints. It's kind of the directions for what road to use, okay? So looking at this first example here, it's a little hard to see, but it's really important that I have an open dot here and a closed dot here, okay? So first thing I'm thinking is, okay, where's my graph getting carved up into the 2 parts? And I see that's going to happen right here, okay? So the left side of my graph is going to happen when my x values are 2 or less, right? They could be equal to 2 here because I've got a closed dot. Okay, and the right side of my graph is going to happen when the x values are greater than 2. They can't be equal to 2 for this side though, right? So that's going to be the constraint parts of my graph, all right? So then I need to come up with equations for the lines. All right, so I'm thinking y equals mx plus b. So let's see, on this one, my y-intercept appears to be -3. And then my slope, I'm just going to choose 2 points that are look like they're on the graph. Or actually, I could have used that one. So, but I'm going down 2 to the left 1, right? Down 2 to the left 1 to get from point to point. So my slope is going to be -2 over 1, which is just -2. Okay, and then my y-intercept is negative 3. So let's see. Y then equals negative 2x minus 3. Okay, so there's my graph for that line on the left side. Okay, I'll just color code this here. So for my red one, let's think about that. Okay, the slope is pretty easy to find. I can choose any 2 points, and I'm going up 1 to the right 1. So my slope over here is going to be 1. Okay. The y-intercept's a little trickier because it doesn't show where it crosses the y-axis, but you can just imagine if you continue the line, you go down 1 to the left 1 and down 1 to the left 1, and it would cross at positive 1. So even though it doesn't, the whole line isn't drawn, if you drew the whole line, it would the y-intercept would be 1. Okay, so thinking y equals mx plus b, then y is going to equal 1x plus 1, or just y equals x plus 1. Okay, so now we've got these two equations, and we've got the constraints. Okay, so now let's put it all together. I'm going to do this at the top here in that little space at the top. So I'm going to say f of x equals, okay, I'm going to do these funny brackets, and I've got two different equations. So I'm only putting in, I'm using f of x instead of y. I'm putting in this part of both of these functions. Okay, so it doesn't matter which one goes on top. I'm putting this one on top and this one on bottom, but you could flip them. Okay, and then I want to say, when am I going to use negative 2x minus 3? I'm going to use that when my x coordinates are less than or equal to 2. And I'm going to use x plus 1 when my x values are greater than 2. Okay, and then there we go. I've got my piecewise function. It takes a little practice, a little getting used to. Okay, this next one has 3 sections. All right, so I'm kind of thinking in my mind of splitting this up into 3 parts, like so. Okay, and let's see. I'll start with the constraints. So this is going to be when x is less than or equal, because that's a closed dot, negative 3. Okay, in the middle, we're going from negative 3 to positive 3. The negative 3 is not included, but the positive 3 is, because we've got a closed dot down here and an open dot up here. So this middle part is going to go from negative 3 to positive 3. So our x values are going to be in between those. Okay, it can't be equal to that one, but it can be equal to positive 3. So it's going to be x values that are greater than negative 3 and less than positive 3, right? So that's how I can write that as an inequality. And then over here, these are going to be x values greater than 3. But I got an open dot, so that part's not going to be included. Okay, and then let's write equations. The easiest equation to write is this one that's a horizontal line, because horizontal lines are just going to be y equals something. All of these points have the same y coordinate. They all have a y coordinate of negative 3. So this part's going to be y equals negative 3. Okay. In the middle, let's go for the middle next. So I can see my my y-intercept is 0 because it goes through the point 0, 0, right? And then my slope, let's find the slope. I'm just going to count points. So I'm thinking, okay, so it looks like I'm going down 2 to the right 1. So my slope is going to be negative 2. Okay, so then we can write an equation for that using y equals mx plus b. And then you could write plus 0, but you don't really need the plus 0. Okay, so I got 2 equations down so far. Let's find the last one. I'm going to separate this out a little bit. So on this side, let's find the slope. So the slope's going to be positive 1, up 1 to the right 1. So 1 over 1, or just 1. And then my y-intercept, I kind of have to look, well, where would this end up if I kept going up 1 to the right 1? Where is it going to cross the y-axis? It would cross the y-axis at positive 1. So y equals 1x plus 1, or just y equals x plus 1. Okay? And now I've got all of the equations, and I've also got all of the constraints at the top of those little parts. So I'll write my function up here. Okay, I want to make this one a little bigger because I got 3 different equations. So I'm just going to do these from left to right, and I'm only using this piece because I already said f of x equals these 3 different things, right? So I've got x plus 1, or negative 2x, or negative 3. And then I'll put in my constraints. So I'm using x plus 1 if x is less than or equal to negative 3. I'm using that middle one if I'm in this zone, between negative 3 and positive 3, with the positive included but not the negative. And then this is when my x's are greater than 3. Okay. All right. All right, next up, we're going to look at a step function. So a step function is a piecewise function. It's a special type of piecewise function where each section is a horizontal line. Okay, so here we've got a picture of one. So that's what a step, it looks like steps, right? Looks like a staircase. So if you look at this, think of the top row there, y equals negative 2. Well, that's just a line where all the y coordinates are negative 2, like that, right? Same thing with all these. Y is just going to equal those different things, those different numbers, which will give you horizontal lines, okay? So we're going to look at a word problem that uses a step function now, okay? A landscaper rents a wood chipper for 4 days. The rental company charges $100 for the first day and $50 for each additional day. So the price is going to go up from day to day, kind of like this one, right? We'd be on some price, and then second day the price will go up, third day, and so forth, okay? All right, so we're going to write and graph a step function that represents the relationship between the number of days. We'll use the number of days as our x coordinate, and the cost in dollars as our y. Okay? All right, so let's just do the graph part first. Okay? So it's $100 for the first day. So, okay, if we all the way up through our first day, it's going to be $100. Okay? So even if you only rent it for 1 hour, there's still a $100 charge for renting it for 1 day or less. So that's going to be our first step, right? Anywhere in there, that's a closed dot there. Okay, and then when we get over 1 day, when we start the second day, the price is going to jump up. It's going to jump up an extra $50. Okay, so that means for anywhere up through the end of the second day, it's going to be it's going to cost $150, right? So this is open here because at the 1 day mark, it's still going to be the 100-day price. But anything beyond the 1 day mark is going to be $150 until we get to the third day, and then it's going to jump up $50 up again. Okay, and it's going to follow that pattern one more time. So this is what our step function is going to look like. So we have 4 different steps, so we're going to have 4 different equations, okay? So I'm just looking at these equations. You can think of this would be y equals 100. All the y coordinates there are 100. This is y equals 150, this step, and so forth. Okay? So then let's put this all together. Okay, instead of using y, I'm going to use f of x to make it a function. And I gotta make this kind of big because I got 4 different pieces. So I'm just going to put those 4 numbers. You can put them in any order, it doesn't matter. So maybe I'll start with the 100 at the top. Okay, y could equal those 4 different things. And now I just have to put in the constraints. Okay, so for the first one, you can say this is when x is less than 1. And technically, it's less than or equal to 1. You could technically say it has to be between 0 and positive 1 because you can't rent a wood chipper for 0 days or negative days, right? But I'm not worried about the negative days because that doesn't make sense here. But you could put, between 0 and 1, okay? For my next step, I'm going to put this is between 1 and 2. So I like to line it up like that, and then I think, okay, this can't be equal to 1 here, so my x's are going to be greater than 1. You know, alligator's eating the bigger one. If x is greater, then the arrow goes that way. Okay, but it can be equal to 2, and 2 is greater than x, so the alligator's eating the 2. The 2 is bigger than the x, right? So that means it's going to be between those two things. And once you get that figured out, it's going to follow that same pattern for the rest of these, because we have the same kind of situation happening where we've got an open dot on the left and a closed dot on the right. Okay, so next I'm going to, for the 200, I'm going to be between 2 and 3 days on the number line with the 3 included. And then for the last day, we're going to be between 3 and 4. Okay, and there's my step function and the graph. And that's the end of the section, and I'll see you next time.